The term artificial neural network, it refers to a biologically inspired subfield of artificial intelligence that is trying to model the human brain. An artificial neural network is usually a computational network based on biological neural networks that construct the structure of human brain. Similar to a human brain that has neurons interconnected to each other, artificial neural networks also have the neurons that are linked to each other in various layers of the network. These neurons in ANN are also known as nodes. So this is the structure of a human brain neuron. So here you have the dendrites that connect different neurons. This is the cell nucleus, this is the axon, and this is the synapse. Now I'll show you a picture of artificial neural network and how it tries to mimic the connections of neurons in human brain. So here you have the input layer where all your input features go. Then you calculate the weights and biases for different neurons. These are input nodes, these are the neurons in hidden layer. And finally, after weights and biases are calculated, and after reducing the error using backpropagation, you finally have the output Y. So let's compare them. Over here, you have a biological neural network, and here you have artificial neural network. So the dendrites will act like the inputs for your ANN. This is the cell nucleus, and this is the node in ANN. Synapse, the weights, and axon is the output. So this is a very good analogy between biological neural network and artificial neural network and how they work. An artificial neural network in the field of AI, where it attempts to mimic the network of neurons that make up the human brain, so that computers will have an option to understand things and make decisions better and in a human like manner. The artificial neural network is designed by programming computers to behave simply like interconnected brain cells. There are around 1000 billion neurons in human brain. Each neuron has an association point somewhere in the range of 1000 to 1 lakh. In the human brain, data is stored in such a manner as to be distributed, and we can extract more than one piece of this data when necessary from our memory parallelly. We can say that human brain is made up of incredibly amazing parallel processors. We can understand the artificial neural network with an example. You can consider a digital logic gate that takes an input and gives the output. Let's take OR gate, which has two inputs. If one or both the inputs are on, then we get on in the output. I hope you're familiar with what is an OR gate in your high school science or mathematics. Then we get on in the output. Now, if both the inputs are off, then we get off in the output. Here, the output depends upon the input. Our brain does not perform the same task. The outputs to inputs relationship keep changing because of the neurons in our brain which are continuously learning. So this is the structure and architecture of ANN. So here you have your input layer where all your features are given as the input, and these are the hidden layers. This is the hidden layer 1, this is the hidden layer 2. As you can see, this is a completely connected dense neural network, so each node is connected with other one, and then these, after these two hidden layers, you have this output layer. So over here you will get the output, and all the calculations of weights and biases will be done over here in the hidden layer, and these will take your features of the dataset as the input. So consider it as like a classification problem. Let's say you have different input features based on the IQ of the student, the CGPA, and a different academic history of the student. You want to predict whether the student will be placed or not. So here you will have the probability for student getting placed, and here the probability of not getting placed. All the features will be given as the input, and you will get the output. So this is the working and architecture of the artificial neural network. Now these input signals are are passed ahead, and once in the training set, the output is tested with the actual data whether the student was placed or not. So comparison, after comparing the actual output and predicted output by the neural network, these error signals are back propagated and based on these error signals, the weights and biases of the nodes keep on changing, so to reduce the error and to make more accurate predictions. Once the neural network has completely learned, then finally you get your complete error-free output. So this was the basic introduction of artificial neural network. I hope you are clear with the concept and working of ANN. Thank you for watching. Now let's move to the next video.